Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800/800 guy, is teaching calculus this year. Watch his videos.
Alright folks, what's up? This is another episode of Calculus. Today we're going to be trying to answer this question. Is there an x such that x is an integer where the limit of x as it approaches 3 of 2x squared minus 3ax plus x minus a minus 1 over the denominator exists? So we have to find an x, an integer x, such that the limit of this function exists. So what should we do? Well, the first thing you should do with any limit question is, especially if you're trying to solve it analytically, is just try to plug in, try to see if the function is continuous. So that's what we're going to try to do it first. Plug x in, see if f of x is continuous. So let's just plug it in. So the limit as x approaches 3 of so let's plug in x, 2 times 3 squared minus 3 times, we already run into a problem, which is that we don't even know what the value a is. But regardless what the rest of the numerator is, if we plug in 3 in the denominator, what do we get? We get 3 squared minus 2 times 3 minus 3. What does this simplify to? 9 minus 6 minus 3. And that's obviously a 0. Now you can't have zeros in the denominator, which is why it turns out that the limit of this function is undefined. But that's not the question. The question is not what the limit is. The question is what value of a makes this limit defined. So we have to find that value of a. So how do we do that? Well, it turns out that if this function f of x has a hole, so let's say this is the graph of f of x, right? If this graph f of x has a hole, then its limit will be defined, right? Because the limit from the right side will equal the limit from the left side. So how can we make a hole by making up some value of a? Well, this is what we can do. We can say that, let's factor out the denominator first. X squared minus 2x minus 3 is equal to x plus 1 times x minus 3. So why did I factor out the denominator? Well, it turns out that if something from the denominator, namely 3, if I can cancel out something from the numerator with this x minus 3 factor on the denominator, then the limit will exist, because then I will have a hole created at x equals 3. So that's my goal. My goal is to make is to find a value a on the numerator such that the numerator is a multiple of x minus 3. So I've simplified the problem a little bit. So now I know that x minus 3 times some factor that I don't know, let's call it x plus k, is equal to the numerator. Okay, so I have the left hand side, right hand side, and now my goal will be to simplify the left hand side to the point where I can find out what a is. So let's do that. So x squared minus 3x plus kx minus 3k is equal to the right hand side. Okay, what can I do now? Let's multiply the left hand side by 2 so that we get that leading coefficient of 2 for the second degree variable. So if I do that, what do I get? I get 2x squared minus 6x plus 2kx minus 6k is equal to 2x squared minus 3ax plus x minus a minus 1. So my goal here is to find the value of a, right? So what do I notice immediately? I see that the left and right hand side both has 2x squared, so we can forget about that 2x squared. Yeah, that seems about it. Let's factor out this x over here. So if I factor out this x, what do I get? I get, let me make it negative. So 6 minus 2k minus 6k on the left hand side, and on the right hand side I get, if I factor out minus x, I get 3a minus, what is it? 3a minus 1 minus a minus 1. So let's check if we factor out right. So minus 6x plus 2kx minus 6k minus 3ax plus x, right? Minus 1 minus a minus 1. Okay, so I have this factored out negative x here on the left hand and right hand side. So that means that these two statements must be equal, whatever is inside the parentheses. So we set them equal to each other. 6 minus 2k equals 3a minus 1. And now even better, we have a second set of equations. Minus 6k equals minus a minus 1. So now we actually have a system of equations, and we have only two variables. So that means we can okay, so that means we can actually find out a, because we have two variables, we have two equations. So let's do that. Minus a minus 1. I have a negative 6k here, so I'm going to try to get negative 6k over here by multiplying both sides by 3. I multiply both sides by 3 so that I get 18 minus 6k equals what? 3 times 3 is 9a minus 3. Great. So now I have a negative 6k here. I already know what negative 6k is, right? So let's plug in. 18 minus 6k is the same as minus a minus 1. Okay, now we are very close to finding a. So let's take up the space here. So you can see here the left hand side simplifies to 18 minus 1 is 17 minus a is equal to 9a minus 3. So you probably already found out in your head. Add a to both sides, add 3 to both sides. Sorry, not 30. This 17 plus 3 is 20. So now we find that a is 2. But is that the answer? Well, technically yes, but we still don't know what the limit is. So how do we find the limit? Well, by now you probably forgot what the question was. The question was, we have to find the value a so that this limit is defined. And we found this limit, we found this value a. So let's find the limit. So the limit as x approaches 3 of 2x squared minus 3. We know that a is 2, so we can just plug in. Minus 3ax plus x minus 2 minus 1 all over x squared minus 2x minus 3. What does this simplify to? Well, I have limit as x approaches 3 of 2x squared minus 6x plus x minus 3 over x squared minus 2x minus 3. This over here, minus 6x plus x, that simplifies to minus 5x. And we are almost done, but if you still plug in 3 over here, it will give you an undefined value because you'll have a 0 in the denominator. So what I'm going to try to do is factor out both the numerator and denominator so that I can cancel out a common factor. So let's factor out the denominator. This one's easy. X squared minus 2x minus 3 is going to become x plus 1 times x minus 3. Right? Does that work? 1 minus 3 is negative 2. 1. Okay, good. But how do we factor this out? Well, you can complete the square, but I find it better to use the quadratic equation. So let's see. What's our a, b, and c values? Our first coefficient is 2, second is negative 5, and third is negative 3. Okay, so let's use the quadratic equation based on these three values. Negative 5 is just positive 5. Square root of negative 5 squared minus 4, a times c. So 2 times minus 3 is negative 6. Over 2 times a, so 2 times 2 is 4. Notice that this simply becomes a perfect square, so that makes life easier for us. And now we have the two solutions. 5 plus 7 is 12 over 4. 5 minus 7 is negative 2 over 4. So now we have our two solutions for the quadratic, which are 3 and negative half. So 3 and negative half. So what does that mean? That means we can factor out the numerator now. Okay, so let's factor out the numerator. What do we get? We get the limit as x approaches positive 3. Numerator simplifies to x minus 3 times, what is this? Is this 2x plus 1? Yes. And denominator we already factored out before as x minus 3 times x plus 1. And now this is the step we've been waiting for. We chose the perfect value for a so that we could arrive at this step. And that step is to cancel out the common factor of x minus 3. So when you eliminate this common factor, now your limit has become defined because you've removed the discontinuity at x equals 3. So once you've done that, now you can just go ahead and plug in. This x minus 3 disappears. It doesn't disappear, it becomes 1, but that doesn't matter. We're looking for x equals 3, so let's plug in 3. So 2 times 3 plus 1 over 3 plus 1. 2 times 3 plus 1 is simply 7, and 3 plus 1 is 4. So the limit as x approaches 3 of this function is 7 over 4. So thank you for watching, and we'll see you in the next episode.
Bari Science Lab to fall in love with math and science, especially programming.